Okay, now we're looking at the fourth question of the 2023 AP Calculus exam. This is actually the fourth FRQ for both the AP Calc A, B, and BC versions. So this was the same problem. So it's a problem that is a tale as old as time. If you've done any practice AP exam questions before, you've probably run into a question very similar to this. There are a couple of things in which they try to change it up a little bit in the subsections, but you'll see that for the most part, it's pretty familiar territory. The function f is defined on the closed interval from -2 to 8, and it satisfies f of 2 being equal to 1. And we're actually given the graph of f prime, or the derivative of f, which is made up of two line segments and a semicircle, as we can see here in this graph. So the first part is asking us, does f have a relative min, a relative max, or neither at x is equal to 6? So we're looking at this point here, and we're trying to determine if that is a relative extrema or neither. Well, looking at this here, in order for it to be a relative extrema, we know that the derivative must have a sign change. Well, we see that since we're given the graph of f prime, we notice that f prime is above the x-axis prior to it hitting 6. So it's going to be positive here. F prime is positive here. And then at 6, it's going to be equal to 0. But right after that, it continues to stay positive. So f prime is positive both before and after 6. So we would then say f has neither a relative min or a relative max, because f prime does not change signs, And a lot of times, students will make the mistake at thinking that a derivative or an extrema occurs when f prime is simply equal to 0, but as we've seen time and time again, that is not the case. What's most important is that there is a sign change at that value in order for it to be a relative extrema, okay? All right, now in part B, they're then asking on what open intervals, which is just a way for us to write our notation when we give our answers, if any, is the graph of f concave down. Give a reason for your answer. All right, so in order for it to be concave down, we know that the function must have its second derivative must be negative. So what we're looking at is the second derivative of f. Well, the second derivative is going to then be the slope of the tangent line of f prime, the rate at which f prime is changing. So we need to go through this graph and we need to look at the slopes. We can see that from -2 to 0, I'm going to do this with colors here, from -2 to 0, we see that f prime's slope is negative because the function is decreasing there. From 0 to 4, the function has a positive slope because it is increasing there. And from 4 to 6, again, our slopes of our tangent lines are going to be negative, right? We can kind of imagine these negative tangent lines here. And then from 6 to 8, we're back to having positive tangent lines. So we can then just say, on what open intervals, if any? Well, f is concave down. You don't have to use that language. Actually, you do. That's what they have written in the problem. All right, it's concave down on our open intervals from -2 to 0. Okay, again, highlighting kind of what we had here, -2 to 0, and 4 to 6, because, and here's our justification, because f double prime, or our second derivative, is negative. And another way of saying this here is you can also say, and I'll write both, you only have to give one, or f prime is decreasing. And a lot of people might choose to actually use this language instead, that f prime is decreasing on these intervals, Okay? All right, let's move on to part C. And I've just reproduced the graph here, so we can just kind of quickly do this. All right, find the value of the limit of, and I'm not going to read all that, you can see that right over there. Well, first thing I always like to do when I'm doing a limit, I just try to see if direct substitution works. Again, I'm not stating that anything I'm doing right now is actually equal to the limit, but I'm just doing some direct substitution to see what I get. And some of you probably already have a pretty good feeling as to what's going to happen here. So if I just try plugging in here, we have 6 times f of x, Well, and we're looking at this limit as x approaches 2. So all of this as x approaches 2 is going to be then, that's just going to be 1 minus 3 times 2 all over, well, that's 2 squared, which is 4, minus 10 plus 6. And all of this is just going to come out to 0 over 0. Well, there's indeterminate form. Indeterminate form. Okay? And since we have indeterminate form, oh, by the way, if you weren't clear as to what's going on here, we're looking at the limit as x approaches 2 of f of x, not f prime of x. And the reason we get 1, remember, f, we would say, is going to be the integral of f prime of x dx, depending on where you're integrating it from. Okay, so that's how we would find the actual value of f there. And if you just look at the area underneath the curve, we would say that it would be positive 1. And you might be looking at this and thinking, hey, I've got less positive area than I do negative area. And we'll talk about this more in the next part, but keep in mind, we are told that f of 2 is equal to 1. So we apply the fundamental theorem of calculus. We actually have to reverse the sign of our area, and that's why we get positive 1 there, not negative 1. So going back to all this, we should see that we have indeterminate form. So that's usually a good sign that we want to use L'Hopital's rule. So I want to show the individual limits, as usually the case. And although they didn't specify that you have to use L'Hopital's rule, if I know I'm going to be using L'Hopital's rule, I want to show the individual limits. So state that the limit of x of 6 times f of x minus 3x, that turned out to be 0. And that the limit as x approached 2 of the denominator, x squared minus 5x plus 6 is equal to 0. Therefore, by L'Hopital's rule, and I'm just going to abbreviate there, and if I were actually taking the AP exam, I would write out the words L'Hopital's rule, but for now, I'm just going to abbreviate. Therefore, by L'Hopital's rule, I can say that the above limit is then equal to the limit as x approaches 2 of the derivative of our numerator and denominator. So the derivative of our numerator, that's just going to give me 6 times f prime of x minus 3. And the denominator would be 2x minus 5. And f prime of 2, so then we have to look at what's going on at 2 of f of x. And at 2, we see that our value is going to be equal to 0. So all of this is just going to be 0 minus 3 in the numerator, which is negative 3. And in the denominator, 2 times 2 minus 5, that's going to be equal to negative 1. So this would just be equal to 3. So the limit of all this just turns out to be equal to 3. All right. And let's go ahead and clean this up a little bit, actually, because we're going to move on to the final part of this question. So find the absolute minimum value of f on the closed interval from negative 2 to 8. And we're going to justify our answer. Well, when we're finding absolute minimums, well, we want to consider the endpoints and any relative minimums. So we're going to start by looking at where our derivative might be equal to 0. So f prime of x, where is our derivative equal to 0? Well, we've got a couple zeros here. We've got negative 1, the aforementioned 0.2, and we've got 6. So that's going to occur at x is equal to negative 1, 2, and 6. So if we were doing the candidate test, we'd want to include these values. However, since we know that we're finding the absolute minimum value, we actually don't need to consider negative 1 and 6. Well, why is that? At negative 1, we notice that our derivative went from positive to negative. Positive values to negative at negative 1. So if you think about the graph, if your function was increasing and then decreasing, there's no way that would be a relative minimum. That would actually be a sign that you actually have a relative maximum there. So I don't need to consider negative 1. At positive 2, we went from negative to positive here. So again, negative to positive, if our function went from decreasing to increasing again, then that would be a relative minimum. So I'd consider 2. And again, at 6, we go from positive back to positive. So actually, we established already there is no extrema there. So there's no way that that would be a relative minimum. So we really only need to look at 2, plus the endpoints, which are at negative 2 and positive 8, or I should probably put that on the number line so it's not too confusing. At negative 2 and positive 8 there, okay? So before I go, so I'm going to set up my table here. I'm going to say x and f of x, and I always usually just set up a table whenever when I'm trying to find the absolute extrema. So the endpoints were -2, our possible relative extrema, which could be the absolute extrema, +2, and then +8. And we're going to actually find the f of x values. Now, in order for us to do this, we've got to remember the fundamental theorem of calculus using this initial condition here. So we're told that f of 2 is equal to 1. So at this point here, the function gives an output of 1. So really just thinking about the fundamental theorem of calculus and its application of the start plus accumulation, we can say that f of x must be equal to 1 plus the integral from 2 up to t of f prime of t dt. Again, this is just FTC. This is the fundamental theorem of calculus, okay? So really that means every time we are evaluating the function at a particular t value along the x-axis, that would be our upper bound here. So if we're testing -2, for example, f of -2 would be 1 plus the integral from 2 to -2 of f prime of t dt. And we actually don't need to do any integrating because we actually have the graph in front of us, and so we can easily find the areas underneath the curve to find the integrals just by finding the areas of these geometric figures. So we actually don't have to do any integrating. But notice that we're going from +2 to -2. Again, because we're going from positive to negative, we're going to need to reverse the signs. So you can even rewrite this, although you don't need to here. You can rewrite this as the integral from -2 to +2 of f prime of t dt and make this negative. So that's another way of doing that. If you want to write this as well, you could do that. In any sense, we know that from -2 to +2, we're just going to go ahead. We already have 1 as our initial condition, so we've got to have that. And then we're going to find the areas of these triangles here. So we can do 1/2 base times height. So times 3 times 2. And then the other one, the negative, 1 times 2, you can probably use those symbols, and that should give you 3, okay? So 1 plus 3 is 4, minus 1 is equal to 3. All right, we're good there. F of 2, that is given to us, that's just going to be equal to 1, right? So far we know that -2 cannot be the absolute minimum. Well, what about 8? So again, I'm going to just show my basic calculations here. We've got 1 plus 1/2 times 2 times 2. Again, we're integrating this time from 2 to +8. So what's nice here is you know that you're just going to have some positive areas. You don't actually need to do any flipping of any signs, right? But we are going to need to kind of think about splitting this up as one triangle plus the area underneath the curve here. If what we have here, this being a semicircle, right? So we have 1/4 of pi with a radius of 2 squared. So that's just going to be equal to pi. So that's the area of each quarter circle there, if you will. So in any sense, we can just go ahead and subtract those areas underneath the curve. So let's see, we've got 1/2 plus 2 times 2. So that's our triangle, right? That was this triangle here. So the area underneath that curve, we know that the area of the entire circle would be pi r squared. So that's just going to be, let's see, pi r squared. So 1/2, so 8, I can write it like this. 8 minus 1/2 pi times 2 squared times 2 squared. Let me actually zoom in on this. I don't know why I'm writing it so small. And that all of that should be, let's see, let's do this quick math. 11 minus 2 pi. I think that should work. 11 minus 2 pi. So putting everything together there, looking at all of our values, 3, we said that this couldn't work. 1 was a good candidate. This is definitely positive. So we can say that the absolute minimum has to occur at 2, but be careful about how we write our answer. They're not asking where it occurs, they're asking for the actual absolute minimum value. So we would say the absolute minimum value of f is 1. All right. So that was the final part of the 2023 AP Calc A, B, and BC FRQ exam.